Okay, let's consider the following example. I have four different vectors. We'll call this vector A1, 1, 3, 6, minus 2. Vector A2 is 0, 1, 2, 0. A3 is 1, 4, 9, minus 4. And the fourth vector, A4, is 2, 2, 2, 0. And we want to know, does the span of these four vectors span all of R4? And so that is equivalent to asking, given any vector b in R4, is it possible that we can find a linear combination of vectors a1, a2, a3, and a4 so that we can get vector b? And from the previous video, we learned that this question is exactly equivalent to saying, does matrix A have a pivot in every pivot column? So does this have a pivot in every column? Where vector A is going to be the vector that consists of columns A1, A2, A3, and A4. So let's set up the matrix A. Again, the first column is just corresponding to the first vector A1. The second column is vector A2. The third column is A3. The fourth column is A4. And so now to answer the original question up top, we can work with this matrix A, and let's try and put this into reduced row echelon form. And if after putting it into reduced row echelon form, we can see that every single column of the matrix has a pivot, then we know that the answer to this question is yes. We can get any vector in R4 by taking some linear combination of these four vectors. So the point here is not to go through elementary row operations. I'm assuming that you've had a lot of practice with that so far. So the first thing we do is some replacement operations to get zeros beneath the pivot in the first column. So I see column 1 has a pivot. And then we come over to the next column, and this column also has a pivot. So the next step would be to get zeros beneath that pivot. So we do another replacement operation, and now we have the following replaced third row in this. And then lastly, we can see that let's eliminate the entries below this pivot by doing another replacement operation. And this last operation would be, let's replace row 4 with 2 times row 3 plus row 4. And so when I multiply this by 2, that kills off the minus 2 over here. And over here, we would get a minus 4 plus 4, so we have a 0 over here. So we have a pivot in the first column. We have a pivot in the second column. We have a pivot in the third column. We don't have any pivot in the fourth column. So since this matrix A, which consists of columns of each of the four vectors in our spanning set, well, since this matrix had no pivot in the fourth column, we notice that there is a row of 0. So here we do have a row where there's no pivot. And that's going to tell us that not all vectors in R4 sit in the span of these four vectors.